Hello and welcome. So in the last video we talked about the electric field due to a uniform circular ring at a distance r from its axis. So today we are going to discuss the gravitational field due to a uniform circular disk on its axis at a distance r. So you see I've drawn a disk here and this is the axis of the disk, and at the distance r from this origin I've considered point P, and here we have considered an elemental area that is of radius x and width dx. So the area of this disk area of this element will be 2 pi x dx. I've written here, and the whole mass of this disk will be m. I've just considered this, and the total radius of this disk is a, so the area will be pi a squared. So we'll be finding its density, so the density becomes rho equals m by pi a square. Now I've already told you that the area element is 2 pi x dx, so I can find the mass element from here. So to find the mass element we need to just multiply the area element with the density, and that will give me the mass of this elemental area. So I've multiplied this the density and the area element, and here you see after multiplying and after cancelling out these two pi's I've got this. And we know from the previous video that for a uniform circular ring at a distance r from its axis, the gravitational field becomes gmr by r square plus x square to the power 3 by 2, where x is the radius of that ring and r is the distance of the point from the center of that ring. So I made use of that formula and written this, and up next we are going to do the calculation. So I've taken 2gmr by pi a square, that is the constant part, and I'll write this x dx by r square plus x square to the power 3 by 2 here. And you see that the limit of x is from this point to this point, that is from radius 0 to a. So I'll put the limit here and find the total field. So we'll be doing a substitution here, so we can write r square plus x square equals z square, and since here for a certain distance I can practically consider r as constant, so taking the differential of this equation we can write x dx equals z dz. So we can write 2gm r by pi a square. Now z is from r to root r square plus s square, and x dx is z dz, and r square plus x square is z square, so this thing in the denominator will be z cube. So 2gm r by pi a square integration from limit r to root r square plus s square 1 by z square dz. Now you know this is just a basic integration, and I can just do it to gmr by pi a square, and this will be minus 1 by z. Now all we need to do is we need to put the limits and our result will be ready. So before that I need to remind you a little thing. This is a mistake that I have done, that I've not cancelled the pi here, so I'll be just doing this. So I've cancelled the pi out. So now our result becomes 2gm by a square 1 minus r by root r square plus s square. So this will be our answer, and I hope you like this. See you in the next video.